Today's topic is piecewise functions. You're going to be able to graph piecewise functions and evaluate them at certain points. So what a piecewise function is it's pieces of multiple graphs. You can see here we have three different equations, x plus 3, x squared, and 3. So we have three pieces of a graph, and you determine where the pieces go based on these boundaries right here. So the x plus 3, that is if x is less than -1. Well, the -1 right's here, and I like to call these parts the fences, they're the borders. So less than it would be to the left, so this section right here is the line x plus 3. The middle section is between -1 and 2, that's right here. And we can see that looks like a part of a parabola, such as x squared. And then the last one, just 3, that's just a horizontal line where x is greater than 2, so that'd be to the right. And what we're going to be doing today is learning how to graph just certain pieces of the graph, but not the entire graph through. Okay, before we get going, we're going to review some inequalities. There's 4 inequalities: less than or equal to, greater than or equal to, less than, greater than. The equal to's have a line underneath them, and that means they're including that point. So when you graph it with a closed colored-in circle, while the less than, greater than, if they don't have a line under it, it's not including that point, so you graph it with an open circle. Just a reminder, less thans are to the left, greater thans are to the right. Alright, so let's graph one. Follow along with me on the graph you have on your notes. I like to start with the boundaries, or what I like to call the fences. My inequalities tell me my fences. I'm graphing where x is less than 2 and where x is greater than or equal to 2. So I have a fence or boundary at 2. So I'm just going to draw a line there to help mark and remind me that that's where part of my graph is going to be to the left and part of my graph is going to be to the right. I highly encourage you to use multiple colors on this. However, you are welcome to just use one color. Now we're going to start graphing. Today we're going to be doing all linear graphs. Y equals mx plus b. As a quick reminder, b is the y-intercept. It's where you start the graph. M is the slope. And we do it rise over run. So I'm going to graph the very first line. -x plus 2. Now if it doesn't have a number in front of x, it's an invisible 1 over 1, so my slope is -1 over 1. I'm going to start graphing it at my y-intercept at 2. I'm going to go to my y-axis, put a dot at 2, and then my slope is negative, so I'm going to go down 1 to the right 1, down 1 to the right 1, and I can keep doing plenty of dots going in both directions till I get a good idea of what my line looks like. However, I'm only going to graph where x is less than 2. Less than would be to the left. So I'm only going to graph left of my purple line. And because my inequality was just a less than, on my boundary I'm going to draw a big open circle, and I'm going to draw to the left. So I'm only going to draw that piece of the graph. Let's do the second line. Visible 1 over 1 in front. This y-intercept is at -2. And it's a positive slope, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I can keep drawing plenty of dots so I have a good enough idea of what the line looks like. Now this one, x is greater than or equal to 2. That means I'm going to be to the right of my purple fence, and because it's an equal to, I'm going to color in a solid line, solid dot. Now these just happen to cross at the same point. They won't always, but these do. Now I'm going to graph to the right of my fence. There you go. And what we just graphed there was 2 pieces of a linear line that made an absolute value graph. Let's try another example. Again, I'm going to start with my fences. Same thing, I'm going to have a fence at 2. I'm going to draw my fence. Alright, let's start by graphing the first line. I can make this -3 into a fraction by putting a 1 under it. So now I'm going to start at my y-intercept at 2. And this slope is -3 over 1, so I'm going to count down 3 to the right 1, down 3 to the right 1, and I can keep going as many dots as I need. Now, to decide which side I'm graphing, look at the inequality. X is less than or equal to 2. The less than tells me I'm going to the left. The equal to tells me on my fence I'm drawing a nice closed circle. So I'm going to make it nice and big and obvious. And then I'm just going to draw to the left of the line. So I'm going to go up like this. Arrow. So that's the only piece of the line. I'm not going to continue it. I'm going to graph my second line. This one starts at a -4. And its slope is 1/2. That means up 1 over 2. Up 1 over 2. Up 1 over 2. Now on my fence, my inequality says x is greater than 2. The greater than means I'm going to graph to the right, but there's not an equal to, so I'm going to draw with an open circle right on the fence, and then graph to the right. Please make it very obvious if it's an open or closed circle. Alright, let's try one more. We're going to graph and then we're going to evaluate some points on the functions. I want you to try graphing on your own, so pause the video and try graphing it. So we have a fence at 2. First line, I'm going to put a 1 under it. I'm going to start at 1. And slope of down 2 over 1. Down 2 over 1. It says x is less than, so I'm going to go to left, or equal to 2, so I'm going to have a closed circle on my fence, make it nice and obvious. And to the left, I'm going to just draw this section of the line. Next one. This one I started at -4. 1, 2, 3, 4. And this slope is 5 over 1, so I'm going to count up 5 over 1. Up 5 over 1. And one more, even though I'm going to go off the graph, it's okay. Up 5 over 1. My inequality says x is greater than 2, not an equal to, so I'm going to draw an open circle. And greater than tells me I'm going to go to the right, so I'm going to go off my graph here, up to the right. Now I'm going to do some evaluating. First, is it a function? To tell if it's a function, we can use something you learned last year, the vertical line test. What the vertical line test is, can I take a vertical line, vertical going up and down, and move past my entire graph and only hit one point at a time? Now the trick comes with piecewise is on the fences. Right here, I have 2 points. But because one of them's a closed circle, that point's included, while this open circle is not included, so technically I only have 1 point on a line there. Everywhere else it would only cross the graph once, so since it passes the vertical line test, yes, it is a function. The next thing we're going to do is we're going to evaluate at certain points. Now we've replaced x, instead of having f of x, we've replaced it with numbers. Well, to evaluate, we need to decide which of our 2 equations are we going to plug x into. So let's look at the graph where x is a -4. So count over. 1, 2, 3, 4. Well, that's on this side of my first graph. So we're going to plug into the first equation. So -2, instead of x, we're going to plug in the -4 plus 1. Negative 2, negative 4, that's positive 8, plus 1, 9. Let's do the same thing with the next one. This time where x is 8, so count to 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's off the graph, but we can clearly see it's going to be somewhere up here with my blue line, my second equation. So we're going to plug into this second equation. 5 instead of x, 8 minus 4. 5 times 8 is 40, minus 4, 36. The last one, that's our trick one, f of 2. 2 was our fence, and so we had our 2 points. We have our open circle, and we have our closed circle. The closed circle is where it's included, so that's the point we're going to be using. And that goes for my first graph, negative 2 times 2 plus 1. Negative 2 times 2 is negative 4 plus 1 is a negative 3. We can even check it by counting on the graph. At 2, we go down 1, 2, 3. Hey, there's the point. Okay, if you still need some help, rewatch this video or watch the additional resources. If you're good to go, get working on the assignment.